Welcome to the channel Next Gen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Data Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Your startup has never implemented a formal security policy. Currently, everyone in the company has access to the datasets stored in Google BigQuery. Teams have freedom to use the service as they see fit, and they have not documented their use cases. You have been asked to secure the data warehouse. You need to discover what everyone is doing. What should you do first? The options are: Option A, use Google Stackdriver audit logs to review data access. Option B, get the Identity and Access Management (IAM) policy of each table. Option C, use Stackdriver monitoring to see the usage of BigQuery query slots. Option D, use the Google Cloud Billing API to see what account the warehouse is being billed to.
To arrive at the correct answer, we focus on the keywords: datasets stored in Google BigQuery, secure the data warehouse, discover what everyone is doing.
The correct answer is Option A, use Google Stackdriver audit logs to review data access.
Why is this correct? A. Google Cloud Audit Logs provide a detailed, historical record of API calls and actions taken by users, which is the required first step to discover exactly what everyone is doing in BigQuery before applying security policies. Why are the others incorrect? B. IAM policies only show current permissions and who has access, not the actual usage or what actions users are actively performing. C. Stackdriver monitoring tracks performance metrics like query slots but lacks the detailed user activity and data access logs needed for a security audit. D. The billing API is used to analyze costs and account charges, not to investigate specific user activities, queries, or data access patterns.
Your company is migrating their 30-node Apache Hadoop cluster to the cloud. They want to reuse Hadoop jobs they have already created and minimize the management of the cluster as much as possible. They also want to be able to persist data beyond the life of the cluster. What should you do? The options are: Option A, create a Google Cloud Dataflow job to process the data. Option B, create a Google Cloud Dataproc cluster that uses persistent disks for HDFS. Option C, create a Hadoop cluster on Google Compute Engine that uses persistent disks. Option D, create a Cloud Dataproc cluster that uses the Google Cloud Storage Connector. Option E, create a Hadoop cluster on Google Compute Engine that uses local SSD disks.
To arrive at the correct answer, we focus on the keywords: Apache Hadoop cluster, reuse Hadoop jobs, minimize the management, persist data beyond the life of the cluster.
The correct answer is Option D, create a Cloud Dataproc cluster that uses the Google Cloud Storage Connector.
Why is this correct? D. Cloud Dataproc is a fully managed Hadoop service that minimizes cluster management and supports existing Hadoop jobs. The Google Cloud Storage Connector stores data in GCS, ensuring data persists beyond the life of the Dataproc cluster. Why are the others incorrect? A. Cloud Dataflow executes Apache Beam pipelines, which would require rewriting the existing Hadoop jobs instead of reusing them. B. Although Dataproc minimizes management, using HDFS on persistent disks means the data is tied to the cluster and will be lost when the cluster is terminated. C. Building a custom Hadoop cluster on Google Compute Engine requires significant administrative effort, failing to minimize the management of the cluster. E. Managing a Hadoop cluster on Compute Engine maximizes overhead. Additionally, local SSDs are ephemeral and lose their data when instances are stopped or deleted.
Business owners at your company have given you a database of bank transactions. Each row contains the user ID, transaction type, transaction location, and transaction amount. They ask you to investigate what type of machine learning can be applied to the data. Which 3 machine learning applications can you use? Choose 3. The options are Option A, supervised learning to determine which transactions are most likely to be fraudulent. Option B, unsupervised learning to determine which transactions are most likely to be fraudulent. Option C, clustering to divide the transactions into n categories based on feature similarity. Option D, supervised learning to predict the location of a transaction. Option E, reinforcement learning to predict the location of a transaction. Option F, unsupervised learning to predict the location of a transaction.
To arrive at the correct answer, we focus on the keywords, user ID, transaction type, transaction location, and transaction amount. What type of machine learning can be applied to the data?
Correct answers are Option B, unsupervised learning to determine which transactions are most likely to be fraudulent. And Option C, clustering to divide the transactions into n categories based on feature similarity. And Option D, supervised learning to predict the location of a transaction.
Why is this correct? B. Since the data lacks fraud labels, unsupervised learning, such as anomaly detection, must be used to identify unusual, potentially fraudulent transactions. C. Clustering is an unsupervised learning technique that can group the transactions into categories based on the similarity of the provided features. D. Because transaction location is included in the dataset, it can be used as a known label to train a supervised predictive model. Why are the others incorrect? A. The dataset does not include a label indicating if a transaction is fraudulent, which is strictly required to train a supervised learning model. E. Reinforcement learning is designed for sequential decision-making by an agent receiving rewards, not for predicting a target value from static tabular data. Why are the others incorrect? F. Predicting a specific, known target variable like transaction location is a supervised learning task, whereas unsupervised learning finds hidden patterns without predefined labels.
Your company's on-premises Apache Hadoop servers are approaching end of life, and IT has decided to migrate the cluster to Google Cloud Dataproc. A like-for-like migration of the cluster would require 50 terabytes of Google persistent disk per node. The CIO is concerned about the cost of using that much block storage. You want to minimize the storage cost of the migration. What should you do? The options are: Option A, put the data into Google Cloud Storage. Option B, use preemptible virtual machines, VMs, for the Cloud Dataproc cluster. Option C, tune the Cloud Dataproc cluster so that there is just enough disk for all data. Option D, migrate some of the cold data into Google Cloud Storage, and keep only the hot data in persistent disk.
To arrive at the correct answer, we focus on the keywords, migrate the cluster to Google Cloud Dataproc, 50 terabytes of Google persistent disk per node, minimize the storage cost.
Correct answer is Option A, put the data into Google Cloud Storage.
Why is this correct? A. Cloud storage is significantly cheaper than persistent disk. Dataproc integrates natively with cloud storage as a Hadoop-compatible file system, allowing you to minimize storage costs by decoupling compute from storage. Why are the others incorrect? B. Preemptible VMs reduce compute costs, not block storage costs. The primary concern is the cost of 50 terabytes of persistent disk per node. C. Tuning the cluster to use less disk doesn't address the fundamental issue that persistent disk is more expensive than cloud storage for storing massive datasets. D. Storing all Hadoop data in cloud storage is the standard Dataproc best practice to minimize costs and decouple storage from compute. Keeping hot data on persistent disk unnecessarily increases costs.
You work for a car manufacturer and have set up a data pipeline using Google Cloud Pub/Sub to capture anomalous sensor events. You are using a push subscription in Cloud Pub/Sub that calls a custom HTTPS endpoint that you have created to take action of these anomalous events as they occur. Your custom HTTPS endpoint keeps getting an inordinate amount of duplicate messages. What is the most likely cause of these duplicate messages? The options are: Option A, the message body for the sensor event is too large. Option B. Your custom endpoint has an out-of-date SSL certificate. Option C. The cloud pub/subtopic has too many messages published to it. Option D. Your custom endpoint is not acknowledging messages within the acknowledgement deadline.
To arrive at the correct answer, we focus on the keywords push subscription, custom HTTPS endpoint, duplicate messages.
The correct answer is option D. Your custom endpoint is not acknowledging messages within the acknowledgement deadline.
Why is this correct? D. Pub/sub expects an HTTP success status within the acknowledgement deadline for push subscriptions. If your endpoint takes too long to respond, pub/sub assumes message delivery failed and resends it, resulting in duplicate messages. Why are the others incorrect? A. While large messages might take longer to process, message size itself does not directly cause duplicates. The core issue is the failure to acknowledge within the deadline. B. An invalid or expired SSL certificate would prevent the push subscription from establishing a secure connection to the endpoint, resulting in total delivery failures, not duplicate messages. C. Cloud pub/sub is designed to handle high message volumes. High throughput alone will not cause duplicates unless it overloads the endpoint, causing it to miss the acknowledgement deadline.
Your company uses a proprietary system to send inventory data every 6 hours to a data ingestion service in the cloud. Transmitted data includes a payload of several fields and the timestamp of the transmission. If there are any concerns about a transmission, the system retransmits the data. How should you deduplicate the data most efficiently? The options are: Option A, assign global unique identifiers, GUID, to each data entry. Option B, compute the hash value of each data entry and compare it with all historical data. Option C, store each data entry as the primary key in a separate database and apply an index. Option D, maintain a database table to store the hash value and other metadata for each data entry.
To arrive at the correct answer, we focus on the keywords retransmits the data, deduplicate the data most efficiency.
The correct answer is option A, assign global unique identifiers, GUID, to each data entry.
Why is this correct? A. Assigning a GUID to each data entry before transmission is the most efficient deduplication method. It allows the ingestion service to instantly identify and filter out exact duplicates during retransmissions without requiring complex computations or large historical comparisons. Why are the others incorrect? B. Computing hash values and comparing them against all historical data is computationally expensive and scales poorly, leading to significant performance bottlenecks. C. Using an entire data entry as a primary key is highly inefficient for storage and indexing, which would significantly slow down database operations. D. Maintaining a separate database table for hash values and metadata introduces unnecessary operational overhead and complexity compared to simply using a pre-assigned GUID.
Your company has hired a new data scientist who wants to perform complicated analyses across very large datasets stored in Google Cloud Storage and in a Cassandra cluster on Google Compute Engine. The scientist primarily wants to create labeled datasets for machine learning projects, along with some visualization tasks. She reports that her laptop is not powerful enough to perform her tasks and it is slowing her down. You want to help her perform her tasks. What should you do? The options are: Option A, run a local version of Jupyter on the laptop. Option B, grant the user access to Google Cloud Shell. Option C, host a visualization tool on a VM on Google Compute Engine. Option D, deploy Google Cloud Data Lab to a virtual machine, VM, on Google Compute Engine.
To arrive at the correct answer, we focus on the keywords complicated analyses across very large datasets, machine learning projects, visualization tasks. Laptop is not powerful enough.
The correct answer is option D, deploy Google Cloud Data Lab to a virtual machine, VM, on Google Compute Engine.
Why is this correct? D. Google Cloud Data Lab is an interactive, web-based tool built on Jupyter running on a VM. It natively supports data analysis, machine learning, and visualization, solving local resource constraints. Why are the others incorrect? A. Running a local Jupyter instance fails to address the root problem because the laptop lacks sufficient computational power. B. Google Cloud Shell is a command-line administration environment, completely unsuited for heavy data analysis, machine learning, or visualization. C. Hosting only a visualization tool on a VM addresses visualization but completely ignores the core requirements of large-scale data analysis and machine learning.
You are deploying 10,000 new Internet of Things devices to collect temperature data in your warehouses globally. You need to process, store and analyze these very large datasets in real time. What should you do? The options are: Option A, send the data to Google Cloud Data Store and then export to BigQuery. Option B, send the data to Google Cloud Pub/Sub, stream Cloud Pub/Sub to Google Cloud Dataflow, and store the data in Google BigQuery. Option C, send the data to cloud storage and then spin up an Apache Hadoop cluster as needed in Google Cloud Dataproc whenever analysis is required. Option D, export logs in batch to Google Cloud Storage and then spin up a Google Cloud SQL instance, import the data from cloud storage, and run an analysis as needed.
To arrive at the correct answer, we focus on the keywords, Internet of Things devices, very large datasets, in real time.
The correct answer is option B, send the data to Google Cloud Pub/Sub, stream Cloud Pub/Sub to Google Cloud Dataflow, and store the data in Google BigQuery.
Why is this correct? B. Cloud Pub/Sub is ideal for high-throughput IoT ingestion. Dataflow provides real-time streaming processing, and BigQuery is designed for storing and analyzing very large datasets in real time. Why are the others incorrect? A. Cloud Data Store is a NoSQL document database and is not optimized for high-throughput real-time IoT data ingestion or analytics. C. Cloud storage and Dataproc are typically used for batch processing and do not satisfy the requirement for real-time processing and analysis. D. Exporting logs in batch does not meet the real-time requirement, and Cloud SQL is not suitable for processing very large datasets compared to BigQuery.
You have spent a few days loading data from comma-separated values, CSV, files into the Google BigQuery table click_stream. The column DT stores the epoch time of click events. For convenience, you chose a simple schema where every field is treated as the string type. Now, you want to compute web session durations of users who visit your site, and you want to change its data type to the timestamp. You want to minimize the migration effort without making future queries computationally expensive. What should you do? The options are: Option A, delete the table click_stream, and then recreate it such that the column DT is of the timestamp type. Reload the data. Option B, add a column TS of the timestamp type to the table click_stream, and populate the numeric values from the column TS for each row. Reference the column TS instead of the column DT from now on. Option C, create a view click_stream_v, where strings from the column DT are cast into timestamp values. Reference the view click_stream_v instead of the table click_stream from now on. Option D, add two columns to the table click_stream, TS of the timestamp type and is_new of the Boolean type. Reload all data in append mode. For each appended row, set the value of is_new to true. For future queries, reference the column TS instead of the column DT, with the where clause ensuring that the value of is_new must be true. The remaining options are: Option E, construct a query to return every row of the table click_stream, while using the built-in function to cast strings from the column DT into timestamp values. Run the query into a destination table new_click_stream, in which the column TS is the timestamp type. Reference the table new_click_stream instead of the table click_stream from now on. In the future, new data is loaded into the table new_click_stream.
To arrive at the correct answer, we focus on the keywords, change its data type to the timestamp, minimize the migration effort, without making future queries computationally expensive.
Review the options on screen. The correct answer is option E. Construct a query to return every row of the table click_stream, while using the built-in function to cast strings from the column DT into timestamp values. Run the query into a destination table new_click_stream, in which the column TS is the timestamp type. Reference the table new_click_stream instead of the table click_stream from now on. In the future, new data is loaded into the table new_click_stream.
Why is this correct? E. Querying the data into a destination table while casting the column to timestamp avoids reloading from CSV, minimizing effort, and stores data natively, preventing computationally expensive future queries. Why are the others incorrect? A. Reloading all data from CSV files forces you to repeat days of work, which fails the requirement to minimize the migration effort. B. Running an update statement to populate a new column for every row is an anti-pattern in BigQuery that rewrites the table inefficiently compared to a simple query destination table approach. C. Creating a view that performs a runtime cast means the operation runs on every query, which makes future queries computationally expensive. D. Reloading all data in append mode requires repeating the original load effort and storing duplicate data, which fails to minimize the migration effort.
You want to use Google Stackdriver logging to monitor Google BigQuery usage. You need an instant notification to be sent to your monitoring tool when new data is appended to a certain table using an insert job, but you do not want to receive notifications for other tables. What should you do? The options are: Option A, make a call to the Stackdriver API to list all logs and apply an advanced filter. Option B, in the Stackdriver logging admin interface, and enable a log sync export to BigQuery. Option C, in the Stackdriver logging admin interface, enable a log sync export to Google Cloud Pub/Sub, and subscribe to the topic from your monitoring tool. Option D, using the Stackdriver API, create a project sync with advanced log filter to export to Pub/Sub, and subscribe to the topic from your monitoring tool.
To arrive at the correct answer, we focus on the keywords, instant notification, appended to a certain table, do not want to receive notifications for other tables.
The correct answer is option D. Using the Stackdriver API, create a project sync with advanced log filter to export to Pub/Sub, and subscribe to the topic from your monitoring tool.
Why is this correct? D. Creating a project sync with an advanced log filter to export to Pub/Sub allows for real-time pushing of specific, filtered logs to your monitoring tool. Why are the others incorrect? A. Calling the API to list logs is a polling approach, which does not provide instant notifications. B. Exporting logs to BigQuery is intended for long-term storage and analysis, not for triggering instant real-time notifications. C. Enabling a log sync to Pub/Sub without an advanced filter would send logs for all tables, failing the requirement to ignore other tables.
You are working on a sensitive project involving private user data. You have set up a project on Google Cloud Platform to house your work internally. An external consultant is going to assist with coding a complex transformation in a Google Cloud Dataflow pipeline for your project. How should you maintain users' privacy? The options are: Option A, grant the consultant the viewer role on the project. Option B, grant the consultant the Cloud Dataflow developer role on the project. Option C, create a service account and allow the consultant to log on with it. Option D, create an anonymized sample of the data for the consultant to work with in a different project.
To arrive at the correct answer, we focus on the keywords, sensitive project, private user data, external consultant, maintain users' privacy.
The correct answer is option D. Create an anonymized sample of the data for the consultant to work within a different project.
Why is this correct? D. Anonymizing the data and using a separate project ensures the external consultant can develop the pipeline without gaining access to the real sensitive data, strictly maintaining user privacy. Why are the others incorrect? A. The viewer role would allow the consultant to view the actual sensitive data stored in the project, compromising user privacy. B. The cloud Dataflow developer role provides access to jobs and potentially the data being processed within the internal project, risking exposure of private data. C. Service accounts are designed for applications, not individual users. Furthermore, granting access to the main project still exposes the sensitive environment and data.
You are building a model to predict whether or not it will rain on a given day. You have thousands of input features and want to see if you can improve training speed by removing some features while having a minimum effect on model accuracy. What can you do? The options are: Option A, eliminate features that are highly correlated to the output labels. Option B, combine highly codependent features into one representative feature. Option C, instead of feeding in each feature individually, average their values in batches of 3. Option D, remove the features that have null values for more than 50% of the training records.
To arrive at the correct answer, we focus on the keywords: thousands of input features, improve training speed, removing some features, minimum effect on model accuracy.
The correct answer is option B, combine highly codependent features into one representative feature.
Why is this correct? B. Combining highly codependent features reduces dimensionality, improving training speed. Since redundant features offer little additional predictive power, replacing them with a single representative feature simplifies the dataset while maintaining model accuracy. Why are the others incorrect? A. Features highly correlated to the output labels are the most predictive. Eliminating them removes critical signals and would significantly degrade the model's performance. C. Averaging arbitrary groups of features destroys their individual meaningful signals, blending unrelated data points which will significantly hurt model accuracy. D. A high percentage of null values could itself be a predictive pattern. Removing features solely based on a 50% null threshold might eliminate useful signals without attempting imputation.
Refer to the attached Picture 1, reference exhibit. Your company is performing data pre-processing for a learning algorithm in Google Cloud Dataflow. Numerous data logs are being generated during this step, and the team wants to analyze them. Due to the dynamic nature of the campaign, the data is growing exponentially every hour. The data scientists have written the following code to read the data for a new key features in the logs. You want to improve the performance of this data read. What should you do? The options are: Option A, specify the table reference object in the code. Option B, use .from query operation to read specific fields from the table. Option C, use of both the Google BigQuery table schema and table field schema classes. Option D, call a transform that returns table row objects, where each element in the P collection represents a single row in the table.
To arrive at the correct answer, we focus on the keywords: read the data for a new key features, improve the performance of this data read.
The correct answer is option B, use .from query operation to read specific fields from the table.
Why is this correct? B. Using .from query allows executing a SQL query to select only the specific fields needed, reducing the volume of data transferred from BigQuery and significantly improving read performance compared to reading the entire table. Why are the others incorrect? A. Specifying a table reference object instead of a string table name is just a syntactic alternative and does not improve data read performance or filter the data. C. Table schema and table field schema are used to define the structure of a table, typically when creating or writing to a table, not for optimizing read operations. D. BigQuery I/O read already outputs a P collection of table row objects. Applying another transform after reading the entire table does not reduce the initial data read size or optimize the BigQuery read.
Your company is streaming real-time sensor data from their factory floor into Bigtable and they have noticed extremely poor performance. How should the row key be redesigned to improve Bigtable performance on queries that populate real-time dashboards? The options are: Option A, use a row key of the form timestamp. Option B, use a row key of the form censored. Option C, use a row key of the form timestamp #censored. Option D, use a row key of the form #censored #timestamp.
To arrive at the correct answer, we focus on the keywords: streaming real-time sensor data, Bigtable, extremely poor performance, row key be redesigned, queries that populate real-time dashboards.
The correct answer is option D, use a row key of the form #censored #timestamp.
Why is this correct? D. Prefixing the row key with a high cardinality or hashed field distributes writes evenly to prevent hotspotting, while appending the timestamp enables efficient time-based queries for dashboards. Why are the others incorrect? A. Starting the row key with a timestamp causes all sequential writes to hit a single Bigtable node, resulting in severe write hotspotting and performance degradation. B. Using only the sensor ID distributes writes but lacks a time dimension, making it highly inefficient to run time series queries for real-time dashboards. C. Placing the timestamp at the beginning of the row key still leads to write hotspotting, as all incoming concurrent data goes to the same node.
Your company's customer and order databases are often under heavy load. This makes performing analytics against them difficult without harming operations. The databases are in a MySQL cluster, with nightly backups taken using miscldump. You want to perform analytics with minimal impact on operations. What should you do? The options are: Option A, add a node to the MySQL cluster and build an OLAP cube there. Option B, use an ETL tool to load the data from MySQL into Google BigQuery. Option C, connect an on-premises Apache Hadoop cluster to MySQL and perform ETL. Option D, mount the backups to Google Cloud SQL and then process the data using Google Cloud Dataproc.
To arrive at the correct answer, we focus on the keywords: under heavy load, performing analytics against them difficult without harming operations, MySQL cluster, perform analytics with minimal impact on operations.
The correct answer is option B, use an ETL tool to load the data from MySQL into Google BigQuery.
Why is this correct? B. BigQuery is a fully managed data warehouse designed for analytics. Using an ETL tool to move data to BigQuery separates the analytical workload from the operational MySQL database, minimizing impact. Why are the others incorrect? A. Building an OLAP cube on a node in the same MySQL cluster does not fully isolate the workload. Heavy analytical queries can still impact overall cluster performance. C. Maintaining an on-premises Hadoop cluster adds unnecessary management overhead and complexity compared to utilizing a fully managed cloud analytics solution like BigQuery. D. Restoring nightly backups to Cloud SQL provides stale data. Additionally, Dataproc is better suited for Spark/Hadoop data processing workloads rather than standard SQL data warehousing.